All right, so now we're ready to fill in all the coordinates around the unit circle. And remember, we said in the last video that the coordinates on the unit circle are the cosine of the angle whose terminal side passes through that point, and the sine of the angle whose terminal side passes through that point. So before we start going around and doing these, I want to go ahead and remind you of the relationships in special right triangles. First, the 30, 60, 90. So we have a 30, 60, 90. And remember in that one, in this triangle, the side opposite 30 is some value. Let's call it Q. The side opposite 60 is that value times the square root of 3. And the side opposite is that right angle, which is the hypotenuse, is 2 times Q. And then we have the 45, 45, 90 triangle. And in this one, if the leg is Q, the other leg is also Q, and the hypotenuse is Q root 2. Now you may be wondering why you're using Q's instead of X's, and you'll see why in just a second. All right, so what I'm going to do is do the first quadrant here. Let's talk about the 30-degree angle right here. So if I were to drop in that perpendicular, get my reference triangle, this is 30. This is then a 30, 60, 90 right triangle, right? This triangle right here. Now, that means it had this relationship between the sides. Now, this is a unit circle, right? Which means the radius of the circle is 1. So if we look at this triangle that we've drawn and the triangles whose relationship we have up here, that means that 1 is 2Q. And that Q then is 1/2 for this triangle. So then if I wanted to fill in what this, which is the X value of this point, and this, which is the Y value of this point, then that would be 1/2 times the square root of 3, and 1/2 itself. So my first coordinates are root 3 over 2 and 1/2. Now, here's the nice thing about this. If I did this for this first triangle, there are 4 other reference triangles that have that same angle, the same setup. Over here, down here, and down here. I didn't draw that particularly well. That's supposed to be down like this. Now, the ratios in these triangles will be exactly the same because the side lengths are going to be exactly the same. The only difference is going to be whether the X or the Y coordinate is positive or negative. So if you look at this angle, to get here, I would move negative square root 3 over 2 up 1/2. So this is a negative root 3 over 2, 1/2. For this one, I would move left root 3 over 2, so negative root 3 over 2, and down 1/2, so negative 1/2. And for this one, my X value would be positive root 3 over 2, but Y value would be negative 1/2. Got that? All right, so let's look at the 45, 45, 90. That would be right here. Remember, the radius of this is 1. So that means in this case, 1 would equal Q times the square root of 2. So Q would be 1 over the square root of 2, which if we rationalized it, would give me root 2 over 2. So that means that each of the legs of this triangle, which are here and here, are square root 2 over 2. So that means my Y value and my X value are the same. And then I have the triangles that go along with that. Not drawing this very well today. Basically those 4. who are also going to have root 2 over 2 as their x and y, but again, the thing that changes is the sign. We have a negative x value here, positive y value, negative x value and y value, and then positive x value, negative y value. Now, if we think about the 60-degree reference angles, which are this one and this one, all the way around, you can think that essentially these are going to be the 30, 60, 90 triangles that we did for the 30, but the x and the y are going to be flipped, right? Because the 30 and 60 are in different places. So that means essentially this one is 1/2 square root 3 over 2. This one is negative 1/2 square root 3 over 2. This one, and again, it's the magnitudes of the sizes that are being flipped, not the signs, because you're still going in the same direction. This would be negative 1/2, negative root 3 over 2. And this one would be 1/2, negative root 3 over 2. Now we're almost done. So if I were to go back and think about my quadrantal angles, the quadrantal angles, the nice thing about them is that they are actually the easiest things to remember, because this is a unit circle, right? So the radius of this circle is 1. So if I just go out to this point at 0 degrees, I've gone out 1 and I've gone up nothing. If I do the same thing at 90 degrees, I've gone up 1 and I've gone to the x value, none. So it's 0, 1. And I can do that all the way around. Now, this is the unit circle completely filled in, and we're going to talk about in the next video how to actually use this.